So for this sequence, what is the a sub n term? Now, it would make a difference maybe what you're going to let n start with. I think I'm going to let n start with 1 or 0. I'm thinking 0. So if n is 0, let's put this right here. 0, 1, 2, 3, 4, and so on. Then the a sub n term would be what? 1 over 2 to the n, that's a sub n. Or I could write this, 1/2 to the n is a sub n. Same, they're the same thing. And then, does the sequence converge or diverge? As n approaches infinity, what is happening to this sequence? A sub n goes to 0. A sub n is going to 0. The denominator is getting bigger and bigger and bigger. The numerator staying a 1. So the whole fraction is going to 0. Now in 11.2, we're doing this. But now, we are looking at something like this. The series of 1/2 to the n, where n starting at 0 and going to infinity.
Why is that 1/2 to the power of n? Shouldn't it be 2 to the negative n?
It could be that as well.
Because I've never seen it like.
It could be that.
Fraction of
You know,
because then that's group.
let's put that in here.
Because then it looks like it does the whole thing itself. And you don't. And
It could be that. That's all the same. Okay. So now I have it written like this, 1/2 to the n, and I'm doing the sum. So this would be, when n is 0, that's going to be 1/2 to the 0 is 1. When n is 1, that's 1/2 to the first power is 1/2. When n is 2, that's 1/2 times 1/2, that's 1/4. When n is 3, that's 1/8. When n is 4, it's 1/16. And it keeps going forever. And for a big part of this chapter, we want to look at this now and say, does this converge or diverge? And while I might not be answering that question exactly right now, I do want you to see if this converges, the sum. If the sum converges, does this go to 0? No. The sequence is going to 0, but that sum is bigger than 1. It's not going to 0. So we talk about a sequence converging and a series converging, and that's two different questions.